So the junior cert sample paper that the department have released that you had for your Christmas paper, this is 25 minutes of questions. So if I go a little bit quick, just remember that you have a bit more time. I'll break this up into 4 parts and you'll have kind of 4 30-minute sections to have a look at. So we're told here, write the numbers 3, 9 and 25 into the 3 empty boxes. And we're told the answer is 24 over 25. So if the answer is a fraction less than 1, both of these numbers have to be less than 1. So what have we got? 3, 9 and 25. Well, that means the 25 definitely can't go on top. And there's only one option on the bottom. So now the 9 next can't go above the 5. It's greater than 1. Would have to go here, leaving only one option for the 3. Just double check your answer. 3 over 5. If we change this into over 25, it will be 3 by 5, which is 15 over 5 by 5. Add the 9, you can see it does equal 24 over 25. Move on to the next part. We're told to write the numbers 3, 5, 9 and 25, the same numbers, into the empty boxes so that the difference between the two fractions is as large as possible, and use each number only once. So we want the biggest minus the smallest here. That's what you have to identify. So it doesn't say anything about top heavy fractions or anything like that. So the biggest number we can make is 25 over 3. So that's just above 8. So now if you just check the others, we can't make any other number with 9 and 5 and 25 that's anywhere near 8. So that would only leave the 5 and the 9. And the smallest number I can make out of that is 5 over 9. And that will be the smallest, the biggest minus the smallest. It doesn't even ask us to multiply this out, so we can leave it like that, but it will be 75 over 9 minus 5 over 9, which will be 70 over 9 if we include the top heavy fractions here. So question B, a positive whole number, 4 factors and one of them is 9. Well, if one of the factors is 9, write that down. It has exactly 4 factors. One of the other ones has to be 1. If 1 is a factor of every number, and if 9 is a factor, every number that 9 is a factor of, 3 would have to be a factor of, because 3 divides into 9. So if we say 3 by 9 is 27, I think that might give us our number. It's just a bit of trial and error and thinking about the question here. That would be 1 by 27 and 3 by 9 as the factors of 27. Does that, are they the only 4 factors of 27? They are. 9's a factor, so I think that's what we're looking for here. The number is 27. Question 2 starts with Millie baking cakes and selling them at our local market. Millie needs 4 eggs to make each cake, and she has 28 eggs. How many cakes can she make? You're saying, well, 4 eggs, 4 by 7 is 28. So she can make 7 cakes. Nice easy start. Part B is a ratio question. She makes filling for her cakes using only butter and sugar, and the ratio of butter to sugar is 5 to 7. 5 to 7, just jot it down again. One day Millie makes a total of 2.4 kilos of filling. 2,400 grams, that might help. Work out how many grams, there we go, of sugar Millie used to make this filling. Well, we can see here there's 12 parts to every mix. So 2,400 divided by 12 will give us 1 part, which is always what we want in ratio. So 1 part here will be 200 grams. So that would mean 5 by 200 for butter, and sugar will be 7 by 200. You can check here, that will be 1,000, and that will be 1,400, and you can see that adds up to 2,400. So the answer to how many grams of sugar she used would be 1,400 grams of sugar. Part C, Millie is buying flour at her local shop, and the shop has two special offers. Offer A and offer B. She wants to buy 6 kilos of flour and work out which is better value, so we'll work out both. Offer A, 1 kilo bags, $3.50 each, and then the offer is she buys 3 bags for the price of 2. Okay, so 3 bags will cost, well, it's going to cost just 2 of the 350s. She's getting the third one free, so that's €7, and she'll need to buy that twice, so €14. So each €7 is 3 kilos, 3 bags, paying for 2, getting 1 for free, so €14 for A. For B, 1.5 kilo bags are €5 each, so we need 6 kilos, so you might see that it's 4 straight away. We need 4 of these bags by €5, so we're going to pay 20, but then we're going to get a discount of 20%, so you could say 20 by 0.20 to get the discount, or 0.80 to see how much you'll pay, and that's going to be €16. The discount is 4, so offer A here is better value. Part D, she sells the cake for $7.50 and it gives her a profit of 20%, so we can say then that $7.50 is equal to, in percentage terms, 120%. So to get how much it costs her to make the cake, we want 100%. So $7.50 divided by 120 would give 1%, like ratio, and then times 100 to get 100%. So just calculator use really. Your calculator will tell you the answer here. €6.25. Millie has 3,000 in a special savings account. She's selling a lot of cakes. It has an interest rate of 2.5% for 4 years, compounded annually. She does not put any money in or take any money out of the account over the 4 years, and work out the total amount in the account after 4 years. So 2.5% for 4 years. If you haven't been taught how to do it this way, you need to start learning really fast. It's 1 point, or 1 plus the interest rate. 2% will be 0.2. 2.5%, then we just add a 5 at the end, and that's to the power of t, or to the power of the amount of years, to the power of 4. You just type that into your calculator and you get the answer. You will get 3,311, so just over 311 in interest over the 4 years, 0.438, and we're asked to correct to the nearest cent, so 0.44, so 3,311.44. Question 3 gives this diagram showing the percentage of their total sleep that men and women spend in deep sleep depending on their age and years. So we can see here at the age of 18 it seems to be the same, and it's the same again at this point here at 50 years of age, so a big gap here. So there's a 32-year period where the red one is women. All along here get less time spent in deep sleep than men, and then there's a point at which men end up having less deep sleep than women. I wonder why this is. We will discuss in class, but let's see the questions they ask. Jean is 20. Use the diagram to estimate the percentage of her total sleep that Gina spends in deep sleep. So she's 20. Here she is here. Jean is 20. Up to the graph. So it's bang on 16 here, so 16%. Gina sleeps an average of 8 hours in total each night. Work out how many hours Gina spends in deep sleep on average each week. So we want a weekly total here. So first of all, we want how many, we want 16% of 8 hours. That'll tell us how much she spends in deep sleep each night. So that will be 0.16, or just use percentage on your calculator, times 8, which is 80 and 48, 128, so 1.28 hours. Now this isn't in minutes and decimals. And then per week, multiply by 7 on your calculator. Give you 8, 7, 1.96, 8.96 hours. I'm sure the department will allow that as the answer, but in minutes we take our 0.96 and multiply it by 60 to get 57.6 minutes. So this will be 8 hours. If you're asked for it to the closest minute, it will be 58 minutes. Part C, we're asked to use a diagram to fill in the inequality in A below to show the range for which women spend a lower percentage of their deep sleep than men do. We saw this was between the age of 18 and the age of 50. The data in the survey was collected from 6 billion nights of sleep, where a billion is 1,000 million. Well, a million has 6 zeros. So 1,000 will be another 3 zeros. So that's 6 billion. And we want to write this in scientific notation, which you all know. You just have to put the decimal so that the number is between 0 and 10, or well, 1 and 10, excuse me. So 6.0 is where it will be here. So that will be multiplied by, how many places have we moved the decimal? It was here. We moved it in 3, 6, 9 by 10 to the power of 9, or just 6 by 10 to the power of 9. In part E, we're told Philippe uses a linear model to estimate the percentage of total sleep that men spend in deep sleep from 42 to 66. He's using a linear model, so the gap between them all has to be the same, and the gap here is 1.4. So this gap will have to be 0.7. So that has to be 14.3, taking away 0.7. Take away 0.7 or add it on to 12.2 to get 12.9. And check in the other direction, you can see it's 0.7. So we're just asked to complete the table. And then in F, we're asked to use the values in the table. Using the value, Philippe writes the percentage of sleep spent in deep sleep. This is a bit of a tongue twister, as a function of age, for the age being between 40 and 60. The graph of this function is a line with a slope of minus 0.14. Explain what this 0.14 means in the context of the question. So we go back to the diagram and we look between 40 and 60, which Philippe is looking at in the context of this question. It does look like it's pretty linear along here, 40 to 60. So the slope of the line is minus 0.14, as we're told. So what is happening in this question, or what's the context of this? It's looks like the decrease. You can write the decrease in percentage of total deep sleep spent in deep sleep. This whole sentence here for men between 40 and 60 is decreasing at a rate of 0.14. And if we put our own values on here, we have 20 on the bottom, and on the rise we have between 12 and 16, 4. The slope looks like it's minus 4 over 20, 1 over 5, minus 0.2. We had a minus 0.14 for the other slope. So you can say over this 20-year period, men are losing 0.14 hours of percentage of total deep sleep per year. Like if you multiply 20 by your 0.14 or your 0.2, you're going to get 2.8% here of total loss. If you multiply it by the 0.2, you're going to get 4% of total loss as a percentage. So some sort of sentence to explain the decrease in percentage of total sleep spent in deep sleep. If you can write that sentence, I can't say it.